Hi, Mark here with My Engineering. Today we're going to do a quick video just covering a certain topic that was brought to us from one of you regarding non-rigid alignment. So the question is, if you have a scan of something, let's picture this mouse pad here. It's really flexible, so you can scan it on one side, and if you had to flip it over to scan the other side, you can see that there's a little bit of flex there, well, quite a bit of flex there. So if you're to align the two scans to make a single mesh, how can we do that while maintaining just one surface, not multiple surfaces? So the example I'm going to use today, it's a little bit difficult to scan your own hand. I'm sure a lot of you guys have tried, but see, I scanned my hand with the wrist straight, and then I scanned it again with the wrist slightly down. And using the non-rigid alignment tool in Artec Studio, you can actually align this so that you bend one of the meshes to match the original mesh. So I'll show you how to do that here. Alright, so what we're looking at here is the two different scans. They're sort of aligned at the wrist, but as you can see, the hands progressively get further apart further down the scan that you go. So what we want to do is use the align function here. And so by default, you'd be looking at best fit as the number one option in the top of the align tab. When you drop that down, there's 4 different options here. And what we want to look at today is called non-rigid alignment. So from here, you can have the two scans. We'll separate them just a little bit. And you're going to want to select common features on the 2 different scans. You can select the knuckles, right at the base of the thumb. Fixed objects like in this case, a wristwatch actually worked pretty well. And so we're going to just want to select a whole bunch of points just to give it a lot of data on the parts that are common. Right here. As you can see, some of the fingers didn't turn out super great in this scan, but that's okay. For the purpose of this demonstration, we're going to bend them, so we're going to have a nice, more or less common feature anyway. And the wristwatch, because I used hole filling, obviously a wristwatch is something that is very reflective. It's not going to give you a very good surface, but we're going to pretend that this is all looking pretty good. So with a whole bunch of data points for it to work from here, we should be able to get it to try to bend the two together. Might even just give it a couple more just along the wrist here. Say somewhere around here. Maybe one more here. More information that you give it in non-rigid alignment, the better it will probably work. Now it's not perfect, but if you look from the side now, you can see that the scan with the wrist bent downwards has now been stretched to go up. So you actually don't have a whole heck of a lot of surfaces on here. For what I would call 2 very poor scans to start with, they actually align not bad, so you have most of a hand, even though it looks like it was sewn together crudely in a Frankenstein kind of way. That is a really, really, really quick and crude version of non-rigid alignment. So essentially you can take 2 organic things that are flexible and create a single fusion model. So just to quickly recap here, the purple scan is the original scan that we are using as the reference. The pink scan is the one that we want to align to that reference. And then after the alignment process with non-rigid alignment, this is where the pink ended up. So it was stretched up to actually match fairly closely, despite being, I'm going to say, a pretty poor scan. You can see the fingers are a little bit off. It's a pretty close alignment. So I hope you guys find that helpful. You can always let us know your thoughts in the comment section below, or if there's any other workflows you'd like to see, let us know as well. You can also email us at support@myeng.ca. Until next time, happy scanning, and we'll see you in the next video.